Let's take a look at this high-low method problem. Pleasant View Hospitals of British Columbia has just hired a new chief administrator who is anxious to employ sound management and planning techniques in the business affairs of the hospital. Accordingly, she has directed her assistant to summarize the cost structure of the various departments so that data will be available for planning purposes. The assistant is unsure how to classify the utilities cost in the radiology department because these costs do not exhibit either strictly variable or fixed cost behavior. Utilities costs are very high in the department due to a CAT or CAT scanner that draws a large amount of power and is kept running at all times. The scanner can't be turned off due to the long warm-up period required for its use. When the scanner is used to scan a patient, it consumes an additional burst of power. The assistant has accumulated the following data on utilities costs and uses the scanner since the first of the year. Okay, so we have, about 10 months worth of data. We have the number of scans and the utility costs. Okay, the chief administrator has informed her assistant that the utilities cost is probably a mixed cost that will have to be broken down into its variable and fixed cost elements by use of a scatter graph. The assistant feels, however, that if the analysis of this type is necessary, then the high-low method should be used because it's easier and quicker. The controller has suggested that there may even be a better approach. But let's focus on the high-low method on this presentation. Okay, requirement 1 says, using the high-low method, estimate a cost formula for utilities where X represents the number of scans, and that would be the variable rate should be stated in terms of cost per scan. All right, let me slide up so we can see how we would solve this. And I'll try to keep the data on the screen and see if I can get all of this on the screen here. Okay, I'm not going to be able to get it all on the screen, but I'll move it as we talk here. Okay, so what do we do with the high-low method? What we do is we choose the highest level of activity and the lowest level of activity. So looking up in the data, we look at the number of scans, the number of data points, and the highest level of activity occurred in July. Now it's important to recognize that you need to pick the highest level of the activity. That's the independent variable and not the highest utility cost. So we don't scan the Y variable or the dependent variable, which is the cost. We instead scan the activity base or the independent variable, the number of scans, the independent activity here. So July is 150, so we write down 150, and the utility costs that go with it is 4,000. We put that down right here. Then we scan again looking for the lowest level of activity, and that occurred in January with 60. So we take 60 and the 2,200, write that down here. Then we book the change. We subtract the low level from the high, we come up with a change of 90 scans and a change of $1,800 between the highest level of utility cost and the lowest. All right, let me adjust the screen here, and then we can complete our analysis. So if we take the change in cost, the $1,800, divided by the 90, we come up with the variable rate, which is $20 per scan. Then if we start at the high level, we knew we had $4,000 if we take the 150 scans, which was the activity at the high level, and multiply it times the variable cost component that we just computed, which is $20. We're able to determine that $3,000 of that $4,000 represents the variable cost. If we subtract the variable cost from the total cost, we've computed the fixed cost. So the cost formula is Y, which would equal the utility cost, is equal to a fixed cost component of $1,000 plus $20 per scan, which is our variable cost component. Okay, and then all we need to do is slide away our little cover sheet here, and we come up with that $1,000 plus $20, which is the answer that we needed to solve for requirement 1. Okay, next we tackle requirement 2, which appears right here. Now I've adjusted the screen so we still have the answer to requirement 1, which is Y equals $1,000 plus $20 per scan. Requirement 2 says, using the high-low method, find the total power cost for 85 scans. So here's the answer down here. We know that we've got the $1,000 we're going to pay regardless of the number of scans that we have. And then we need to multiply the 85 times the $20 per scan, which came from that portion of requirement 1, our cost function, and we come up with $2,700. And we jot that in, and that takes care of this problem, everyone.